Good morning, everyone. It's 10:50, so I'd like to get started with the session. My name is Jonathan Rathsam. I'm from NASA Langley Research Center, and this is a session called Applications of Machine Learning and Uncertainty Quantification. We have three speakers. First speaker is from university. The second two are from the national labs. I think it's going to be a great session. I'm going to introduce our first speaker, Himanshu from Florida International University. He's been there for 21 years, leading the artificial intelligence, cybersecurity / big data group. And he's also a co-PI on work from Department of Defense, Defense Intelligence Agency, and the Department of Energy. So please welcome Himanshu.
Thank you. Good morning, everyone. So my talk is split into two parts. One, actually, I'm going to go over the slides, and then actually I'll try to do the live demo of the system. So those of you who are not aware of FIU, Florida International University is a public university located in Miami, Florida. We are among the top 10 largest public universities in US with 58,000 student body here as of 2022. We also have a top tier research designation, R1 Carnegie classification for highest research activity. It is one of the biggest Hispanic serving institution, awarding bachelor's and master's degree in different fields actually. With that, so before I go into actually the advanced automated machine learning system demo, I want to give you a background. There was a research that was funded by Department of Defense Test Resource Management Center. And that was to develop a cyber threat automation and monitoring system to monitor cyber threats that can be modeled on where the mission can be modeled on this platform. So there are four platforms of this system. On the top left, you see is a virtualization platform. So basically, we have instrumented the hypervisor so that they can watch there are agents that are watching actually the VMs that are running and executing the mission. So it's kind of a more cloud environment, but located within the center. And as you can see here, it has introspector, smart memory acquisition. All those are the instrumentation components that are available here on the virtualization platform. On the right, you see is a AI-based analytics platform. We started in 2016-17 timeframe to build this integrated system. And at the bottom, you see is a test control center that manages the virtualization and AI analytics platform for cyber application, looking into the mission that is modeled on this using this system. And at the bottom left is the test vector repository, which is basically nothing but a repository of custom malwares that will impact the mission that is modeled on this using this system. So when you go to the little details, I'll not go into the details of those components here, but just wanted to share that all the instrumentation that was done at the hypervisor is actually looking into live memory of the virtual machines as the mission is executing on that platform and extracting multiple data structures that is pushed to the analytics platform. But this was integrated with the CTAM system, and the TRMC cyberspace test technology actually asked us to take this AI platform out from here and make it more general purpose. And that's how we build a new architecture that can not only support the cyber, but any domain that has data and that's stored in the environment. So what you see at the bottom is kind of an integrated CTAM system that was extracted and then put into advanced automated machine learning system. So before I go into that system, I just wanted to share this three pillars actually of AI and machine learning, and how the AI has been democratized and is being used, commercialized and used in the government and the private industry. So there are three parts to that. On the left, you see is an application domain. So the entire talk is focused on the experts, actually, the subject matter experts who are from the application domain. They know the data, they understand the data and where the data is being captured actually. What you see in the middle is all the packaged technologies. You have heard many talks here talking about AI, ML, different frameworks, different algorithms, different models that are being built using the data that is coming from the application domain. And on the right, once you take the data, you combine that with your algorithms and ultimately you build the model, then the model has to be operationalized. So ChatGPT is one example where model has become a platform in itself. But here, the idea here is how do you operationalize the model? And that's where the IT infrastructure and the application comes into picture. So you have the data from the domain, you have the technology from stats, computer science, computer engineering, and then ultimately you are operationalizing using the IT infrastructure. So my focus is more on the people who are domain experts, subject matter experts, but they have little knowledge of machine learning. But how can they leverage that technology and learn from the pattern that exists in the data that's coming from the application domain? So the one I showed you previously, the advanced analytics platform that was used in cyber, so that now came out. And now you can see instead of that virtualization platform, which you saw previously, now I have data that is stored in network file share or in the relational database system or inside a big data cluster. It is sitting within the organization and the data can be of different types, structured, unstructured, semi-structured, streaming data or batch data. How can we connect to that data using this platform? And that's where this AI analytics comes into picture. As you can see now, the modules are more tailored towards connecting to the data and do the machine learning actually, or in general, the learning framework. At the bottom, we call it Analytics Control Center. That's the third pillar, basically, that provides a very simple user interface for subject matter experts to kind of connect to the data and perform machine learning. So the idea here is we are trying to automate machine learning process as much as possible. Those of you who have experience in developing the models, it's a very monotonous and a tedious process actually optimizing this model. So what we have done here, to a good extent, we are able to automate that process without writing a single piece of programming in R or Python. You should be able to learn from the data here. So this is the AMLS architecture. So what you saw in the CCAM architecture is completely changed here now. And we tried to enhance it or re-architect it actually so that we can connect to the data that is coming from the multiple domain. So the application areas and the domain you see on the top left, it is not limited to cyber. You can have IoT, robotics, energy, water, and environment. The data can come from any of those domains. And then what you have to do is to use this platform to connect to the data. So the other part that we don't want to move the data actually. So we want to keep the network traffic as low as possible. There is no duplication of data. So in real time, you should be able to connect to the data that is stored in that environment. And then you should be able to load the data in memory as and when needed when you're trying to do machine learning there. And in the middle, you can see the data storage and integration. That is part of your IT infrastructure that sits in organization where the data is located. What you need is a credential to connect to that data. That's it. Then after that, at the bottom, you will see the AML processing engine. So this is the kind of a vision actually we have single node cluster implemented in as a part of our research work here. But the idea here is to scale this so that we can take advantage of parallel processing, GPU processing, as well as the big data cluster deployment. And when I say big data cluster, we are looking at Spark cluster for processing here. In the middle is actually the heart of the AML server. Basically, we are having all the communication server, modeling engine, shared server. So that's all used in order to run this system. And the AML database stores all the information related to the modeling, prediction, and the connection to the different data sources. On the top right is actually the ACC server that's giving you all the functionality and web-based functionality in the sense that you don't need any installation on your machine. If you have browser and the connectivity, then you should be able to use this system. And that's what I'm showing at the client workstation browser, where different users from different reasons or functions can work with this platform here. So this is a high-level architecture of the advanced automated machine learning system. And what you see here is a homepage actually, and I'm going to do a live demo of this system, but Just to give you a background here, this was again supported by, funded by the Test Resource Management Center. All of you are familiar with the machine learning workflow. So I'll just kind of go over here to retrieve the steps. So you start from data acquisition, basically, and collect all the data. Then you do the data exploration. Basically, you want to do understand all the stats, the distribution of the data. And then you visualize the data with some graphs, charts, and you will use multiple IT tools to do that. So, and then when you want to use the data for machine learning, some amount of pre-processing is required. There is statistical pre-processing required, and there is a machine learning oriented pre-processing is required. And then you have feature engineering, basically all the attributes that you have to understand, which attributes are the features you want to use to build the machine learning model. And then model selection is basically algorithm selection. And then you have the training of the model, optimization of the model, model validation, and finally the prediction. Once you are satisfied with your model, then you will deploy the model, and that's where the operationalization of the model comes into picture. And then you start using the system in a production environment. We were focused on initially on 4 different machine learning problems for classification, regression, time series, and anomaly detection. So this is a normal data science workflow or AI ML workflow that you are familiar with. What we have done here, of course, you have to connect to the data source. That is the first step. You can do statistical analysis on that with a click of a button. That will be exploration. And similarly, you can do visualization. But the model building, as you can see, there are 7 steps in model building. Here, once you have all the 3 steps, you are comfortable, you want to build the model. It's just a single click of a button, and all the operation is happening in background, actually. So it's an automated process. Once your model is built, you look at the metrics and you are comfortable with the metrics, then you can move on and you can do the prediction. And once a prediction means basically you are deploying the model for operational purpose. And then there are some management modules, actually. So whatever models you have built in the past, or whatever predictions you have done in the past, that all historical information is also kept in the system. And the last part is administration, that gives you the role management and authorization to use different features of the system. So as you can see here, the first step, all the steps are on the left side. You can start with the data source, where you can manage the data sources. It's a one-time operation. If you have the credentials, the data is sitting in the environment where you are trying to use this system. You connect to the data source and store that credential. You can have the data, as I mentioned, in NFS or database or Hadoop system, for example. So you need those credentials, and you have, so we have structured the way it is a training data, and the training data you will use to build your model and do the validation. And once you are comfortable, then you can do the prediction. So once it is created, view data source actually will store all that information so that you can use it in future. The upload files, actually, basically, we are working with multiple national labs now, and the researchers, scientists, chemists, physicists, all those people working in the national lab, they want to upload the data to the system. So that's why we have an upload feature, so that they can upload their CSV files. If you have terabytes of data, that process is not going to work. Most of the scientists and engineers, they are working with the sample data sets that are there in the CSV file or some kind of tab delimited file. They should be able to upload the system here and make use of it. And as you can see here, managed data sources shows you one-time connection that is stored here, that is stored in the secure database, so that it can be used to connect to the different data sources. And this screen shows you actually an upload file that the user from their desktop can upload the file to the system, and then they can make use of the machine learning steps that we have in this environment. Data exploration, once you can see here, we have data source tags, basically two user-defined tags actually that you can use to group the data. So here you'll see that I have some data from preventive maintenance, some cyber data source, and some we had aircraft platform data sources that we got from TRMC. So we have those data sources. So once you can see, once you have the connection, where it is stored, what is the name of the data source that you create in the first step? Just you have to select your features. You don't have to select all the attributes. You can select, filter the attributes and select, and then you can click explore data. Basically, it will do the statistical analysis. Most of you will be familiar with all this, what are the parameters that are there in the analysis. So those things are generated. And the next step, exactly the same process. Now you want to visualize the data in terms of some distribution plot, box plot, and all that, normally pair plot, correlation thing. So you will be writing either R script and Python script. Here it is just one click of a button and all these charts are generated. So these are based on our experience that normally the data scientists will be using to generate these kind of plots to view the data. However, this can be expanded based on the requirement of a particular client actually. So data pre-processing. So this is important step. So we are making data ready so that we can learn, the algorithms can learn from the data. So as everyone know that machine learning has to deal with numbers. So if you have text data, encoding is definitely required, and you have multiple different options for defining your pre-processing. The data is not getting transformed at this stage or pre-processed. We are only collecting that information. As you can see here, the workflow, I have 3 workflows here. So the auto workflow means the user doesn't have to do anything actually. They have to just connect to the data source, and there is default options available for you to run through the process so that you can do the pre-processing of the data. Now, if you want to change the selection, then you also have an option to go to the optimization workflow where you can define your own custom pre-processing options using the optimization workflow here. So as you can see here, you can give a name, a default name for your pre-processing option. So what kind of encoding you want, and the scaling you want to do, min-max scalar or a max absolute scalar or transformation similarly that you can do. If you want to do the PCA, you can do that PCA. So all these selections you can define and store under the pre-processing name here, and you can continue storing these values, and that can be used in future. So the AML database stores all these user-defined choices based on whatever you have defined in this particular module here. And the last one, which is the custom one is actually, if none of those are working, then definitely contact FIU and we will work with you to kind of define your optimization options for pre-processing. And the same thing goes for other module. What you are seeing here is the next step. After the pre-processing step is defined, now the step comes as a model building. And again, 3 workflows there, auto optimization and custom. But now you have a pre-processing option. So you can choose default, which is auto, or you can have an optimization where you have defined your own optimization parameters in pre-processing. Then you define a model name, so user-defined model name that you can have and a description of that. Now you have a list of algorithms that allows you to do regression analysis. If you are doing classification, then you have a list of algorithms that will define the classification algorithm on the data that you are going to apply. Plus, you also see a display hyperparameters option. So these are actually, so when you have an auto, that means you can view all your hyperparameters. And if you are in optimization, then you have the ability to change all those optimization parameters. So the way we see the data scientist, or for example, the subject matter expert will use it, everybody will go with an auto to see how the results are. And then you can go and start modifying those optimization parameters for each algorithm so that you can fine tune your model. So that's how we see that this system will be used actually. And once the model is trained and you will have the validation result. So you can see here for different algorithms. You also have those hyperparameters that were used to define the used with the those algorithms have been used here while for this particular result. And what are the metrics that are used? So we have defined metrics that are available for regression, classification, anomaly detection, those things are available. And of course, then you have some plots also here. Once you are comfortable there, you can go to the next step, which is prediction. Now you have already trained your model. The model is available in the system. You can run multiple tests. That's why we call it as a rapid modeling and testing tool, RMTT here, because you can do a very quick modeling here based on your infrastructure, how much of processing power you have. The performance of the system will depend upon those things. So now you define your test actually. So when we are saying prediction, basically you are running multiple tests here, and the algorithm that were used for building your model are automatically displayed here. Whatever features you have used for building your model, they all will be available here. So this selection will become automatic based on what models were built on. And once you define that, So the only thing that you need to do is to connect to the data source, which is your test data. And then you perform your prediction results. You have the ability to download your test results, plus also what kind of parameters were used. And of course, different plots and all are available for your prediction as well. So simple operation, you start pre-processing, model building, and prediction. 3 steps, 3 click of the buttons, and all the things are happening automatically behind the scene. So management modules are actually whatever models you have built in the past, those are available. All the results, the validation results are also available in the system. So you can go ahead and make use of it. This is an asynchronous operation. So model building, as all of you know, that takes a lot of time depending upon the processing power of the computing power, how much of the data you are using, how many attributes you are using to train your model. So all those things will depend upon that. So what happens is you just click and say, run this model in the background. So that process is happening in the background. And here, when you see the status, it will depend upon how much time it takes. And once it is completed, then it is going to show you it will show in progress initially. And then after that, it will show that the model is complete. And then you can start using for testing purpose. Similarly, prediction also, you can run multiple test runs. Predictions are going to be much faster because now it is just fitting whatever the algorithms you have used on the test data that you have. And so the results will be displayed here. And again, if it is going to take time, then in that case, it will be processing. It will show processing here. This so normally, like we talked about classification, regression, and all, which is classical or traditional machine learning algorithm. But we are also trying to implement image classification, or basically computer vision based algorithms in this case. This is not completed. We are still working on it. We have done one project for Savannah River National Lab, where we are trying to support surveillance and maintenance of nuclear infrastructure. And we are trying to identify the cracks on the wall and then monitor its progress over a period of time. So this task was actually funded by DOE EM headquarters. And so we developed those algorithms, and now we are in the process of importing those features into this platform so that the neural network architecture for the image classification can be generated automatically. So behind the scene, we are going to do that job, but we are still working on that process here. But as you can see here, we are very consistent with the flow. We have at the top, which is classical or traditional machine learning. Then what you're saying, computer vision, and of course, we want to do natural language processing. That will be all the deep learning algorithm that will be implemented here down the line. But the flow is consistent across all the algorithms and the problem sets. And you can see here that these are the different cracks which we are using convolutional neural network and CNN with autoencoder actually to identify the cracks. We are also using YOLO basically, which is object detection algorithm here. So we are using transfer learning with that to identify these cracks. So there are different approaches we are using here to kind of identify and quantify the size of the cracks also. That's the part of the research that's going on there. So once you have the model built, again, as you can see here, we are using CNN. There are some networks that are already available in open source on open source platforms. So they are also integrated. So all these frameworks are becoming the part of your processing engine. So which I showed you the previous architecture initially. So all these algorithms, frameworks, we have experimented with multiple frameworks, and the ones that works the best are being integrated into this platform here. And as you can see here, it is showing you the cracked walls and the smooth walls here. And based on that, so this is a prediction that is happening with the test data that we have fed to these models. So as I mentioned, object detection also, we are using currently YOLO is the one that has been implemented. If you are familiar, that is used with object detection and transfer learning. So we are using those technologies here to kind of identify those objects. And as you can see here, it is generating the bounding blocks, in fact. So, and the important part is you have so much of image and we don't want to duplicate anything. So everything is located in the place where it is stored actually. We are just connecting to that. All the results are stored and displayed here on the screen. So, and similarly, we can continue here. So in the interest of time, actually, I'll move on here. And plus the administration module where the users will have different access and the summary of this part, different steps, 3 or 4 links, and you are able to do the machine learning. What I will do, I'll try to show you a live demo of the system. So that way, what we just covered here, you will be able to see. It runs within the lab. We just brought it. Currently, it is just made live here temporarily for me to demonstrate the system. Okay, so this is a little tedious because I have to show here. So as you can see here, so this is the home page. And so the data source which I was showing you here. So this is saying that's already available here. So if you go to view data sources, so these things are also available here. And you can select different tags here actually. So you can select all tags to see the connections. You can always view them here. And it shows you all the connectivity that is available. If you want to preview the data, you can click on the preview. It brings like 100 sample records to show you. This is a bot data actually, which I'm showing you here. And so once you have the data, it is defined, you can always go to the exploration, select your cyber data. And I'll try to run through that quickly. So basically you're selecting a problem. Let's say you're doing classification. So we are comparing normal traffic as well as bot generated traffic here. And so then you select your, let's say the training data. So as I mentioned, you can preview the data or you can just select the features. So I'll just select all of them. These are your attributes. Once you confirm, and then you just click explore data. So you can see here, dynamically it is showing 40,000 records and different mean, standard deviation, all these things are generated. You go to the next module, and again here, you just select features here. And now you want to visualize and generate some charts here. So you can always just click on a button here. It is now doing real-time processing, and it will try to generate all the charts, and it will display here. 2 minutes. Okay. So maybe it's hard to kind of demo that. So I'll just run through that. So again, I'll just show you the different modules here, data pre-processing. Same thing here. You guys saw that, and when you click the display, different options are there. If you go to the optimization, you have the default option as well as demo options. And once you click on that, you can see here different pre-processing options are there. Model building and prediction are exactly the same way, which I showed you the different workflows here. And once you click on classification, you can see here model name, description. All these algorithms are coming here. And similarly, the prediction module also, if you click on each one of them, it will show you all the different hyperparameters are available here. And so, of course, I talked about all these modules. I can just show you a quick result that is already available here. And you can see view results. So I just ran this morning only. Yep. So as you can see here for different algorithms, the accuracies are different, 96. As you can see, support vector machine didn't do good. So you can skip that in the results section actually. So, and similarly, sorry. So similarly, also you have the prediction, exactly the same way the prediction works. I'm not going into the computer vision module. If you guys are interested, we can chat outside. But that's the live system. So as I showed you, those things are just a simple web-based interface available for using it.
Thank you so much for the presentation.